Okay, so in this video we're going to look at how the group 1 metals react with water. Now this is an experiment that's great fun and you've maybe seen it before, hopefully you've seen it. If you're new, if you're in year 8, you maybe haven't seen this before. So these are the 3 metals that are in group 1 that we were allowed in school. So we've got lithium, sodium and potassium. And you can maybe see from the hazard symbols on the container that actually they're quite dangerous chemicals, they're very reactive. Look at how they're stored different than other metals. So they're inside a plastic container and then inside a jar. Now, I'm not sure if you can see in the video, but inside the jar there's a liquid, and with lithium the metal's floating on top of the liquid. The liquid in here is oil, and it's to stop lithium reacting with any moisture or any oxygen in the air. So whenever we want to take a sample of the metal, we need to fish it out of the oil, which is not very easy. Okay, there's a wee tiny bit. And we're going to use a paper towel, and we're going to make sure all the oil is wiped off, and then put the lid back on. So we've got a little tiny bit of metal. It's not what you would expect for a normal metal. So if you ask me to describe a normal metal, we might not describe what lithium looks like, or sodium or potassium. So you'll see it's actually quite dull. It's very easy to cut, but watch when I cut it to see when I cut it, it's actually quite shiny inside, but then it quickly goes dull. So easy to cut, and then it's shiny, and then it goes dull once it reacts with the oxygen in the air. Okay, most metals don't do that. Most metals you can't cut with a knife, whereas group 1 metals you can. So I'm just going to cut this up into another piece and then show you these pieces reacting with the water. So put the lid on that one. Now lithium is at the top of group 1. It's in group 1 period 2. Remember if you've done that. So once it goes into the water, it floats in the water and it immediately starts to fizz. So our observations for this reaction is that the lithium floats, it fizzes, you maybe hear the fizzing and the bubbles. It moves around on the surface of the water and it just disappears. The metal's getting smaller. I'll breathe them in. The gas that it's producing is hydrogen. So if you think back to your work where we were testing our gases, the test for hydrogen gas is it burns with squeaky pop. So I'm just going to try and prove that this is hydrogen. So listen to the pop. Okay, so that proves to us it's hydrogen. Now that isn't an observation for this reaction. The observation is just that it's fizzing. So remember, an observation is what you see, what you hear and what you feel. So I'll go over those observations again because you maybe need to write those in your booklet. So the lithium floats on the water, it fizzes, it moves around the surface, and then the lithium gets smaller. Okay, so those were the observations when lithium reacted with water. The equation is, so lithium plus water produces lithium hydroxide plus hydrogen, and the symbol equation is written underneath. Now at the end, once I've finished reacting all these metals, I'll show you what it means to have a hydroxide produced. So these are called our alkali metals because when they react with water, they produce an alkali. So lithium hydroxide is an alkali, but we'll also do it whenever we have sodium and potassium. So now I'm going to show you what happens when we react sodium. Again, it's stored in the same type of container. And inside the plastic container is our bottle. And we've got oil in our bottle again, and the sodium this time's at the bottom of the oil. Wonder if you can see it in the video or not. So again, we're going to use the tweezers to fish out a bit of sodium. Now actually, watch what the difference is between the lithium and sodium, because what I can do with the sodium is I can stick the tweezers in it. I don't even need to hold it with the tweezers. See there, I'm not holding it with the tweezers. I was able just to stick it in it. So most metals aren't that soft. I'll probably lift it out more than one bit here. So remember, I'm drying off all the oil. It's one of our safety precautions and our risk assessment that we have to dry off all the oil. So maybe at the top of the page you have to fill in your risk assessment for this. So this is one of the bits about our risk assessment. We don't want to have oil on the metal still when we put it into the water, because we know that oil and water don't mix. So there's a little bit of the oil wiped off it. I'm going to get another wee tiny bit. So sodium is really soft. I'll put that bit back in the bottle. Try to dry a bit with a paper towel. Make sure all that oil is off. Okay. Now again, it can be cut with a knife. So it's a dull colour at the minute. And watch what happens. It goes shiny. It goes dull a lot quicker than the lithium did. So it reacts with the oxygen, but it reacts faster with the oxygen than the lithium did. Okay. And same with this one. Really easy to cut. So let's have a look at what happens when we put sodium into water. So again, we're writing down our observations in your book. So I want you particularly to pay attention to the shape of it is at the start, once it hits the water. So have a look at the shape it's turned into. So one of the observations is that sodium melts into a ball, it fizzes, and again it floats on the surface. Now, sodium has a particular movement around the surface of the water, and we'll see if we can get it with this next one. So again, look at the shape. I'm going to try and drop it into the middle now. So it melts into a ball, and the movement is described as it zigzags across the surface. So it goes in straight lines, hit the side of the bowl, and then it zigzags across. Again, the gas that's being produced, we can just confirm it's hydrogen by seeing if it burns the squeaky pop. Listen to the pop. Don't know if you heard that very well. We'll try it with the next bit whenever it's a bit bigger and see. Okay, and so our observations, it fizzes, the sodium gets smaller, it zigzags across the surface of the water, and it floats. Those are observations. Okay, and then the last bit, so see the way it just melts into a circle. It didn't start off as a circle, pretty cool. Let's see if we test it, see if we can confirm it's hydrogen. There you go, it burns with a squeaky pop. Now it's staying on fire because that's a hydrogen that's burning, so that's not part of the observation of the reaction. So the observation of our reaction again is the fizzing. This time it's maybe, you can maybe see the water's getting a wee bit cloudy underneath. It wasn't doing that with the lithium, but it is with the sodium. Okay, so our reaction then, our equation for sodium is the same as lithium. We've got sodium plus water goes to sodium hydroxide plus hydrogen. And there's a symbol equation underneath as well. So remember, sodium hydroxide is an alkali as well. And then our last one I'm going to show you is potassium hydroxide. So again, we've got our hazard symbols on it to tell us that we have to be careful. Have a look at the difference between the storage. This one is more reactive. As we go down group 1, it gets more reactive. So again, we've got oil in the bottle. I'm not sure if you can see, there's some chunks of the potassium at the bottom. So what do you think? Do you think I'm going to be able to stab this with the tongs the way I did the last one? And if I bring it out, get my paper towel ready. So you see, I did just stab it with one bit of the tong. So again, it's very soft. It's not, these group 1 metals are not like normal metals. They don't have the normal properties. So our properties of our normal metals would be, they'd be shiny, they'd be hard, they'd have high melting points. None of those are true for, well, actually, they are shiny when they're cut, but then they react with oxygen. So let's see with the potassium. Again, it's just very dull at the start. So I'm going to watch how easy it is to cut, and then watch how quickly this goes dull compared to the other two. Probably dull already, is it? So that's just so I'll do 3 bits of this one as well. So another part of our risk assessment is that there's a limit to the size of piece. So I'm only using very small pieces of the metal. So if I just go over the points for our risk assessment, we're wiping off the oil. We're making sure that the bottles are all closed and out of the way before I put the metal into the water. We're using a very small piece, and when I put it in the water, I'm standing back. So watch with the lithium, it's a bit different than the other two because we're getting further down the route, so it's more reactive. So watch what happens when we put lithium in. Pretty cool, eh? So our observations for lithium, it caught fire, didn't it? Burns with a lilac flame. So when we do our flame tests, we know the flame test for potassium is a lilac flame. It fizzles, it fizzes, you can hear the fizzing, it sparks, when we see sparks, it floats on the surface, and we can definitely see the liquid going cloudy this time. And our last piece of potassium, whoa, how's it going? And then our equation for potassium is potassium plus water goes to potassium hydroxide plus hydrogen. So again, those equations are very similar, symbol equations there as well. And the reason that they're called alkali metals is that they produce this hydroxide. So the lithium hydroxide, the sodium hydroxide, and the potassium hydroxide. So if you remember back to our pH scale and what acids and alkalis are, school bell going in the background. So when we add universal indicator to it, we can see that the water, which started off as neutral, has turned to a dark blue colour, which has sodium hydroxide, a mixture of sodium hydroxide, potassium hydroxide, and lithium hydroxide. So it's produced an alkali when the metals have reacted with water. So the last bit I want to show you is just the electronic structure of the three metals. So they're all in group 1, they all have 1 electron in the outer shell, but as you go down the group they get more reactive. I want you to think back to what we were talking about when we did electronic structure, and just have a think and see whether you can describe why they get more reactive in terms of that outer electron. Okay?